Team, it's Mr. Z, and we're going to start lesson 1 of our new unit. Let's take a closer look, shall we? So, in this lesson, we're going to introduce a bunch of terms. I've typed them out, but it doesn't mean you shouldn't write them out. Remember, rewriting is the key to your memory. And the first term that comes to your mind is a function. It is the set of all ordered pairs, x comma y, or x comma f of x. Remember, f of x is the same thing as saying y. And it says every value of x, there's only one and only one value of y. Most things are a function. We're going to compare and contrast things that are not a function later on, but I just want to plant the seeds. The vertical line test deals with a function, and it's used to determine if a relation is a function. If all of the vertical lines hit the graph at most in one spot, then it's a function. If it hits more than one spot, then it is not a function. So for the vertical line test, I am not given any information about A and B. For A, if I go ahead and draw some vertical lines, this first vertical line only goes through the graph one time. This second vertical line only goes through the graph one time. This third graph, or third line, and so on. A graph must pass the vertical line test in all instances. So that summary of what I've drawn out is essentially the process I go through mentally to determine if it passes the vertical line test. So it does. It passes the vertical line test. And then this implies the following. The graph is a function. Let's go ahead and look at our other example. B. So my first vertical line in this test to see if the graph is a function, it only goes through once. I then test my second vertical line, and I see that it fails. If it fails one time, that automatically disqualifies it. So what this would be determined is it fails the vertical line test. And what this implies is that the graph is not a function. So this is part 1 of today. The idea is that if I give you a graph, you can apply and use the vertical line test. You do not know the equation, but you are still able to make a conclusion. It's a function, not a function. The second part of today is invertible. A function is invertible if its inverse is also a function. We're going to talk about inverses in the next section, but basically it means when I switch my x for my y. So if I have the point 1, 2, notice here x is equal to 1, y is equal to 2 because it's a coordinate. The inverse would be the following point. 2, 1. So invertible means that the inverse is also a function. We do not see the inverse. We're looking at the OG. So this horizontal line test is used to determine if a function is invertible. If every horizontal line you can draw hits a function at most in one spot, it passes. If a horizontal line hits a function in more than one spot, then a function fails. Our conclusion. If a function passes the horizontal line test, it is invertible. And if a function fails the horizontal line test, it is not invertible. So looking at the following, C, I can immediately see that it passes the vertical, let me zoom in, line test. What I'm looking at would be considered a function. My horizontal line test. Notice how all those points only go through the graph one time. So it would be considered to pass the horizontal line test. Meaning it is not invertible. Or it is invertible. My bad. Remember, invertible means that the inverse, which is not in the picture, would be a function. This next guy, I go ahead and examine, and I'm going to test if it is a function. So, by repeatedly drawing vertical lines, you can clearly see it only goes through one time, meaning this is a function. It passes the vertical line test. It is a function. However, upon further investigation, my graph does not pass a horizontal line test. It fails the horizontal line test. Therefore, it is not invertible. Meaning the inverse would not pass the vertical line test. This next guy, I notice that it passes the vertical line test. Some students make the mistake of thinking that, oh, if I draw a line, it cuts through the graph multiple times, but the idea is that it goes through exactly one time. Since it passes the vertical line test, that means this is a function. It also passes the horizontal line test. Therefore, it is invertible, meaning that whatever the inverse is would be a function. This guy passes the vertical line test. Therefore, it is a function. It fails the horizontal line test. got to be actually a straight line. Let me be proper. Therefore, it is not invertible. What this means is that if I find the inverse and graph it, it would fail the vertical line test. Not invertible, remember, means the inverse is also a function. Okay. What we can conclude is notice how D and F, they both pass the vertical line test and they both fail the horizontal line test. Squared to the fourth. All even degree powers are not invertible. Odd are invertible. The reason why the C example would be considered odd is because when there is no exponent, it is assumed to be 1. This is the big point of today. I can look at equations and determine if they're invertible or not invertible. Let's take a closer look at some practice. So in all of these, determine if the following are invertible or not and explain why. So I see immediately that it has a odd exponent. Therefore, is going to be invertible. And therefore, it passes the horizontal line test. I do not know what this looks like, but I know that it's going to definitely pass the horizontal line test. It can look something like so. Here, number 2, I see that it is a even exponent. This implies it is not invertible, which means it fails the horizontal line test. It could look something like so. Let's look at some graphs. Number 3. This guy fails the horizontal line test. Therefore, it is not invertible. Four passes the vertical line test. Therefore, it is invertible. Now, with some clever maneuvering, I can make one more conclusion. Because it is not invertible, that implies that the exponent is even. This implies that the exponent is odd. This is the extra level that I can go. Even though I'm not given the equation, I know that number 3 is going to look like something where it says x to an even power. Over here for number 4, without giving the equation, I know it's going to be x to a odd power. I am making this conclusion from the horizontal line test results. Go ahead and try 5, 6, 7, and 8 on your own. This has been it for today. I hope this helped. I will see you all later. Ciao.